Good afternoon and welcome to Design Master Training. My name is David Robison. Today we are going to be looking at breaker curves and selective coordination in Design Master Electrical RT. If you are attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497 and our email address is support@designmaster.biz. So a new feature in the new release that we are currently beta testing is breaker curves. So this is not in the current release of the software. It is in the new 2.0 that's being beta tested. If you don't have that, contact us and we can get you set up with it. It's currently a production beta. We've got lots of people using it on actual projects. So you're welcome to have it if you would like to try it out for us. One of the new features are breaker curves. And you can use these for two different purposes, for selective coordination and for arc flash calculations. You set these in the panel edit command. If I select a panel, panels have a main disconnect type. If I set this to have a main disconnect breaker, and I'll set it to be a 400 amp panel, we can set the breaker curve here for the main disconnect. We also have the breaker curve for the overcurrent protection, so the breaker in the upstream panel. If you try and set it on a panel that's connected to a transformer, there's no breaker in that transformer, so it's going to flag you and not let you make any settings there. I'm going to come down here to MDP1. I'm going to make this a 200 amp panel, reset all my settings. And now we can set our breaker curve for the overcurrent protection. When we press that button, it will display all of the breaker curve breakers that are available for the breaker size that you have selected. So it lists the panel, it lists the trip size of the breaker, and then it lists a number of manufacturers. So you can choose the manufacturer that you're using, and then the specific breaker that you want to use. The list of breakers we have is limited currently. So if you have a breaker that is not in our list, send us an email and we will get it added for you. It's a list that we are expanding slowly based upon customer requests and just other breakers that we feel might be useful. So if you contact us, within a couple days, we can usually turn around an update to the breaker database so that you can use that breaker in your projects. If we go take a look at so that's how you set it in a panel. If you go take a look at the 3D view, we can do the instance edit on this cooling tower, so this branch circuit device. To set the breaker curve here, we've got the same command, and so that's how you would set the breaker curve for a piece of equipment in your project. So those are the two places for panels and branch circuit devices. We can use these curves to actually plot out curves on the drafting view. So we have a number of new commands here in the selective coordination section. I will run graph insert. I'm going to choose that MDP1, and we're going to create a graph with it on our drafting view. It comes in, it's got big X over it, and the curve's not set. I never actually set any settings for that breaker, so it's saying I can't actually draw anything here. It's got the big X telling you should probably go adjust something. We have the curve edit command. You can run this. You can select the specific curve from the drafting view and go straight to modifying it. There's a number of different types of curves that just exist for breakers. The first is the basic thermal curve. If I go to the Eaton curve here, you'll see that I select this FD frame. The instantaneous pickup is fixed. There's really no options for this curve. I click OK, and it'll draft it in for us. So there's the curve based upon that breaker. Run curve edit again. You can have different instantaneous settings for those thermal breakers. If I go to a different Eaton breaker here, take the JD frame. Now we've got options for the instantaneous pickup. I will leave it at 5 times the trip, and it'll give us the curve there. And then you can adjust that setting based upon what you actually need it for based upon typically your selective coordination, and it'll adjust the curve to match. So you run curve edit, select the curve, give it a new value, and it updates. We can do electronic trips as well. I'm going to show a GE breaker here. You've got a couple different options for the sensor, multiple settings, the long time delay, short time pickup, your I2T setting, your short time delay, and then again your instantaneous pickup. Set all of those correctly, and we will draw the curve. We do assume that you have information about the breaker. It's very, very specific to the breaker you're using, what these settings are, what they mean, how they're going to affect this curve. So I would not in general recommend you just pick up the software, choose a breaker, and set some settings and hope it's going to work out. You actually need to know what breaker is going to be actually installed. You probably need to go download the documentation and understand what you're actually setting. Our software has the settings for you, but you need to make sure that you're setting them properly based upon what you've actually got and what you actually want in the field. So we can adjust these to some other values, and it'll put in a new curve. So just adjust a couple, and again, it'll adjust the curve a little bit for you. Those are for electronic curves, that electronic trips that have individual selections for all of the settings. Some of them allow you to basically input a specific number. I've got an example on an Eaton breaker for that. So here, rather than selecting an item, it's giving you the min and max value and then what the increment is allowed by the breaker. And then you type in what the value is going to be. Set that a little bit bigger because I think they'll otherwise overlap. And then it draws it in the breaker again using the settings that you specify. There are cases where the I2T curve and the short time delay are kind of linked. In the software, we don't link them as nicely as they could be, so you do need to make sure to match those. Again, this is where you need to actually be looking at what the settings are that exist on your breaker to make sure that what you're choosing is something that makes sense. So here, if you set the I2T, you've got a couple options for short time delays because this curve actually changes based upon the short time delay that's selected. And that one actually had an error even creating it. So that's why this is still beta software. And we will choose some different settings instead. I think we can get this to draw. There we go. There we go. That's what you would expect from an electronic trip. Some of the settings, if you choose some extreme settings, the curves end up being a little bit odd looking, but that's just how the settings work out. So here you do want to make sure, because as you're changing this value, you're actually getting a different curve, so you need to make sure to adjust the short time delay to match, because this is what the actual curve would look like. And the short time delay is not being shown there because probably my instantaneous isn't quite far enough back. Short time delay is right here. And the final type of curve that we have is we do have fuses in here. So if we take a busman fuse, we'll plot that as well. And those typically end up just being a single line. So that's the curve for a fuse. Using the graph edit command, this is the same as the insert graph. We can adjust some of the settings. So you can set a title, whatever you want the label for the graph. You can actually set a subtitle as well. You can add a note at the bottom. You can also add additional curves. So right now we've got the one MDP. I'll come in here and put LP1 that's connected to it. If you have a piece of equipment, a branch circuit device, you have to use the Select Equipment from Project button. If I click that, I can go here and select this cooling tower as well. Click OK. It will update the labels that we changed, and then it will put in the additional curves, though they're not set. So again, it gives us the big X saying you need to actually put some settings on these. Using Graph Edit, you can modify the pieces of equipment themselves. So if I select this LP1, I can edit the equipment settings. That'll pull up Panel Edit, verify that, okay, this is a 100 amp panel, but it's got 20 amp overcurrent protection. We'll change that to match the bus size. And then we can select that and edit the curve settings here. Actually assign a curve to it. And then we'll do the same thing with the cooling tower. Set the curve settings for it. Click OK. And now that they actually have curves set, it will draw them all in. It draws them in order that you have them created in the graph edit. So if you want to rearrange them, you can select them, and you can, if we want to have the cooling tower as the one at the top, we can put it up at the top. That'll rearrange the list over here. It mainly controls the order that they're listed on the right-hand side, and then which ones will overlap each other here when they're actually drawn. And if you want to get rid of a curve, you can select it, and there's the Remove Curve button as well. And then once you have your curves here, for selective coordination, usually you don't want them to overlap, so you can start adjusting their settings so that they're not actually overlapping each other. So we can come in here and take this graph and try and adjust this curve. So now the instantaneous pickups are not overlapping. You can also make some changes to the appearance. That is controlled in customization in project options. We have this selective coordination graph section. It controls all of the Revit settings for the text sizes, basically the text types and the line types and the fills. So if we come in here and we put in a text type, it'll put that, use that for the title, so it's something a little bit bigger. You can adjust different line styles for your borders and the various other elements of the graph. And just you're basically choosing Revit types there. If they don't exist, it'll choose some default. So you want to make sure that these actually match settings that exist in your project. And after making that change, we can update the graph. And so I've got a bigger text for the title. So you want to make those changes, and then you can use the standard export and import customization commands to pull those into additional projects as well. In addition to plotting these graphs for selective coordination, we can also use them for arc flash calculations. Now for arc flash, we use these to look up the trip time. We also limit the trip time to 2 seconds, which is right here on this curve, this horizontal line right here. The idea being that after 2 seconds, the assumption is that the person in the arc flash will have moved away. So even if it takes longer than that to trip, that the person will not be exposed to the danger any longer than that. So the set of times where the currents that actually have a different time is relatively limited usually. It's just from here, and then once you get over here, they basically are in the long time, and they trip nearly instantaneously. So it's only in these values in between those where it actually has any impact really on the calculation. So getting an arc flash that's going to use something on this curve usually takes a little bit of work to actually get something that matches when I'm doing my examples. So let's take this LP1, and I will set the fault at 10,000 amps, and we will run our calculation. It'll take a moment, and it's going to redo the calculation. And for the trip times, it will calculate these values for us. And it's coming up with 0.0. So the arcing current is 5,000 and 6,000, which is about here. So it's basically hitting this long time, and it's giving us 0.06 seconds. And then if we adjust the fault, that will change the arcing current, and then we'll actually get a different trip time. So if we drop this down, calculate again, I think that'll give us an arcing time, an arcing current in this range. Yeah, it's giving us 1200. So now our times, we're still over here in the long time for the maximum current, but the reduced current is about 1,000. And so that's kind of on this little curve here. So it takes a little bit longer. Drop this down to 1,000 fault, 1,000 amps of fault. The arcing current is going to drop even more, and it'll take a little bit longer to trip. So now we're at 600 and 500 amps for our arcing current. And so we're at 0.2, kind of in this end of the curve. And then those arcing times feed back into the calculation to calculate your incident energy. And then you can use that for labeling your panels for arc flash calculations. You do still have the ability to override the values. You can set this to yes, and you can just type in the times. If we don't have the curve available for you, if you're waiting for us to load it in, or if you have some other situation where you don't want to use these calculated values. All right, we have a question. I'm trying to create an office standard for customization items. Once I get things the way I want them, what is the best way to distribute this to others? And then it also says that the Design Master's shared parameter file is set by Revit versions. I'm concerned that when I change Revit versions, I'll have to recreate any tags I've made. So the first question, how do you share your customization between users in an office? So there are two ways you can store your customization. You can either open up a template file, use our customization commands, and set all the values in the template. And then when you start a new project, you would use that template. So you would distribute that template to people however you distribute your Revit templates for starting projects. You also can export the customization to a file. And then you just need to put that in a place where everyone has access to it, probably on a shared folder somewhere on your network, so that when someone starts a project, they know to run the import and go grab that customization file. We also add one-line diagrams in this new release. So there are going to be one-line diagram families. You'll want to put those in a folder where everyone can get to them. And so I don't know how Revit really handles sharing families. What we chose to do is for our software under user options. So under customization, there's user options. We have a customization folder. By default, it's going to go to your My Documents, I believe, or no, it goes to your application data. So it goes to an app data folder on your C drive. You can point this to a network drive. So you could point it to a network drive for everybody and put all your families there, and then all of your customization will be pulled from there for one-line diagrams. For parameters, you will not need to recreate any tags. Mostly the difference between the different Revit versions is that we are adding things, and so there is additional parameters that exist in the later versions, particularly as Revit adds things. So the parameters themselves don't change. So if you have one parameter that's used, that parameter will live forever in our software in all of our versions. It's only if we add something, it might only exist in the later versions of Revit, so it's only available in that parameter file. Also, as we move forward, we are going to be matching Revit's system for supporting versions of Revit. So we are going to support, I believe they support the current and the previous 3 versions with new development. However, you'll always have access to our old software on old versions of Revit. So 1.4 is going to work through Revit 2017. This new 2.0 is going to work on Revit 2018 and later. So and we've added a bunch of new stuff in terms of shared parameters with this release. So if you're trying to do something in an old version of Revit, you can pull the old shared parameter file and know that, okay, that's the stuff that does actually exist for Design Master. And then if you're using newer versions, the newer shared parameter file. So in general, work with the shared parameter file that's the lowest version of Revit that you're supporting in terms of your families and your projects. And know that anything that you do is going to be supported going forward in our software. Hopefully that answered all of your questions about shared parameters. We definitely don't want you to have to recreate stuff with every version of Revit. That workflow would not work for anybody. And so we are aware of that. So that is not the intention. There's a question, how many graphics can you insert? You can insert as many as you want. So if I go and edit this graph, I can keep adding curves and it will not mind. It just gets to be a very long list and a very messy graph, but it will put them all on there. I believe we have shading for 4 curves, so it kind of just repeats the shading. And if we edit these other curves, you can see that, it obviously is going to start to become cluttered. But you can put as many different curves on there as you need. We don't restrict you. So there we go. So you can have lots and lots of curves on there. And I didn't show this. We also show the fault for each piece of equipment as well. So those are listed, and we do a line there and then cut the curve at the fault. So those are displayed as well. Thank you for watching today's Design Mastery training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmastery.biz.